see my screen and hear me loud and clear as well? Perfect. Thank you for confirmation, everyone. All right, so let us start. So first of all, before we begin our session here, let me start by introducing myself. So my name is Neos on enterprises in different industry verticals, which included and marketing of these enterprise solutions across the global markets, right? And in terms of trading front, I have been working actively as a corporate trainer, having delivered trainings to multiple corporates, including EY, Capgemini, Mercedes, Accenture, Google, Grab. So I've been helping the corporates or the workforce of these companies in getting updated on the current trends and technologies used nowadays for making sure that the application, the solution that they are providing to the clientele is top notch and they are a step ahead of the competition, right? Because we know in this highly competitive world, we have to stay a step ahead in order to beat the competition. And that's exactly what I have been helping these companies in achieving that, right? Now, before we start with the session here, guys, there's a simple single rule that we have to follow for this entire session. So in case you have any questions, in case you have any doubts, any queries coming in on any of the topic that we'll be covering, please feel free to post your queries one by one in using the questions tab so that I can answer that one by one, right? Because our main goal of this entire session is to make this as interactive as possible, right? As we are live now, as we are live. So again, if we don't make it interactive, again, it will be simply like a recorded video, correct? Which we obviously don't want. So if you have any questions, if you have any queries coming in on any of the topic that we will be discussing, please feel free to post those queries one by one so that I can answer it all right? And since we have a good number of participants joining in, now it may happen that sometimes some of the queries may be left unanswered, right? So don't feel disheartened. So as we have now, your queries may get lost in the pile of questions, so don't feel disheartened and keep on posting the same question again and again so that your question can have a good visibility and I can answer it as soon as I have seen it. All right. All right, everyone. So now let's get started on our discussion on introduction to DevOps, right? So the main motive of the main agenda for today's session is, first of all, we'll be understanding why we need to adopt DevOps, what has been different development models that has been followed since the beginning of application development, what exactly DevOps is, what are different components of DevOps, what are different stages involved in DevOps strategy, and then we'll be focusing on different tools, focus on different stages, right? So each and every stage have a set of tools that we use as a part of DevOps, right? So we'll be having a quick understanding on what those tools are, and then we'll be looking at the use case of DevOps. That means how DevOps is changing the development environment, how DevOps is helping global teams in staying ahead and automating the entire task, which needed a quite amount of time before the introduction of DevOps, right? And then at the end, we'll be having a quick hands-on on one of the tools that we have discussed on top of DevOps. All right. So this will be our agenda for today's session here, guys. Now let's get started. First of all, if we remember if we remember the different models that we have been using for software development, right? So we have multiple model types as a part of software development lifecycle, right? The earliest one that we have been using is Waterfall. So we're in Waterfall, what happens, there are multiple steps that we go through in each and every process of development. For example, let's say here we have 7 stages deployed here. We have 6 stages deployed here. First of all, we start with requirement of gathering analysis, right? First of all, that means in this phase, we talk to the clients, we get a good understanding of what the entire project is all about. And then we move to the design phase. Now, where we design all the prototypes for the application. Then once those prototypes has been designed, then we move on to implementation phase, where we implement, where the developers come into play and they develop the code that has been verified and designed by the design team. Then once the first beta version of the application is out, then we go to the testing phase, where we run multiple tests to find out multiple bugs and any kind of issues in the application. And then we deploy it into the real world scenario in the production environment, right? And then we run multiple maintenance jobs on top of it, right? Now, this model looks good. It covers all the basic criteria of any particular development cycle, right? But there was a main drawback. There's a main drawback involved in Waterfall. That is, we cannot go back to the previous stage in any case, right? And if we move to the next stage, suppose if we move from implementation to testing phase, right? Then again, if we're coming back to development, again, we have to wait for each and every process to be conducted, to be executed, and then only we can come back again from the requirement design and the implementation phase here, right? And obviously it took a lot of time, and that's why this process was not that much great. And again, there were multiple issues faced in the waterfall, right? So the main issues that developers and design team faced in waterfall model are, first of all, it had high amount of risk, because again, now let's suppose we design the entire application. Now by the end of testing and the maintenance phase, client came back to us, okay, now they need to make some changes in the entire application, or they made or now, these changes can be small, or this can be a hardcore change. That means, again, this can be change in the entire functionality of the entire application itself, right? So again, these kind of changes, again, it made the entire system unstable, right? And there was a high uncertainty if the application will be successful or not, right? And this model had been good for a small project, but this is not at all feasible for a large scale project. Like suppose if we talk about Twitter, Facebook, Gmail, Google Maps, right? These are large scale applications which are used by billions of users, right? So this strategy will not work at all for these kind of applications, right? Then these are also not suitable for those projects which are continuously changing based now. For example, dashboards, or for example, those applications which run on data. For example, let's say we have Zomato, right? Zomato runs entirely on data. There's no fixed data that we have to show on Zomato, right? So the entire opening and closing hours, the entire menu system, the location of the restaurants, the feedback, these are continuously changing, right? And that's why we need a well planned strategy for making this kind of application successful, correct? Right? And again, as we discussed, if the application moves to testing, again, it becomes very difficult for any developers, for any members of the development team to roll back to the implementation phase if the output of feedback or the testing it was not that much great, right? And again, since we cannot move back we cannot move back to the scale here to the earlier stages, that's why it requires more time, because now we have to wait for the entire cycle to be completed, then only we can come back to that particular stage altogether. All right. So I hope this model is clear for everyone. Please give me a quick confirmation, guys, so that we can now discuss on Agile, how Agile solve the problem of waterfall to some extent, not completely, but to some extent. Perfect. Thank you for confirmation, Firoz, Deepak. Perfect. Next is we have Agile methodology, right? So Agile came after Waterfall. We also had Spiral. We have multiple Waterfall. We have multiple development models, right? Now the next most popular had been Agile. So Agile solved the issue of development, design, and discovery phase as a part of that. These were different stages also involved in Waterfall, right? So Agile solved the issue of design and development, right? So again, these three main components are broken up into multiple iterations. By the term iteration, we can say it simply works like a version itself, right? So here, first of all, we design and develop and discover the first iteration. Then again, we get the feedback on it. Again, we design, develop, and perform the second iteration. That means second changes or second version, third version, and so on, right? But again, the entire iteration, now as a limitation of Agile, each and every iteration needed to be of the same time duration. So we cannot have first iteration for 2 weeks and second one for 8 weeks and third one for 4 weeks. All of these has to be same, right? That means suppose if this is for 2 weeks, the second iteration needs also be of 2 weeks and so on, right? So if we take a look at a comparison between Waterfall and Agile, so Waterfall is completely a sequence based, right? So just like we have an array, right? So here we have entire all the cycles involved in waterfall are planned in sequence ways, right? So we cannot roll back, and we have to wait for one sequence to be executed, then only the second part can be taken care of, right? Whereas in agile, again, the analyzing and planning phase are again in the same queue, right? We have simply made design, building, and testing as a part of entire circular setup, right? So that only these things can have some kind of flexibility in terms of coming back. Rest, analyzing, planning, and deployment thing has to be consistent. All right. And again, agile also had limitations. Now basically any particular setup for any application involves two main teams: development team and the operations team, right? So development team, now now even as a coder ourselves, we may think, okay, once we have developed the entire website, okay, and when we have tested it into our own environment, we may think, okay, now our application is perfect as it is working perfectly as it should in our own laptop or in our own system, right? But as we know, when the same application goes in the market, goes to the actual users, now the entire scenario may change, right? Because here, let's suppose we have tested the application into our Chrome browser into our own home network, and then we have also used our Windows system, right? And if the same application goes to the real world, now if the users are using Safari, Opera, Internet Explorer, Edge, again they are also running these on multiple platforms, on Mac systems, on Linux systems, on Windows, right? Again, now some users may face difficulty, now some users may face issue in the real world, right? And again, that's the problem faced by operations team, right? That means the same code which was working fine with development environment, it is not working as it should have in the real world or in the production environment, right? That's why development team wants change, and the operation teams wants a stability in terms of as the output of the entire application here. All right. And just to make both of these ends meet together, DevOps came into existence, right? So DevOps is simply the combination of two words out there. We have development and operations, right? So here we simply make sure that the development team and operations team, they both work together in making sure the entire quality of the entire output has been improvised exponentially, right? That's a main output, that's a main objective of using DevOps, here. All right. Now, DevOps has multiple phases. DevOps has multiple phases involved. Here we have mainly, now DevOps is a combination of, we can say, continuity. It's a combination of continuity with development and testing, right? So basically in DevOps, we have multiple phases, right? Where we have continuous testing. Now, first of all, we have continuous building, then continuous testing, continuous integration, continuous deployment, and continuous monitoring, right? So there's a common term involved in each and every phases, that is continuous, right? So all of the entire building, testing, integrating the entire application, monitoring it, right? So these all are done in real time continuously, right? So we don't suppose we don't build the code and just wait for the feedback. We continuously keep on building and sending the entire code to the test environments, right? And testing also keeps on happening on a regular basis, right? So because of this continuity in the process, that's why we include the word as continuous in each and every phases here, right? Now, basically, if we have to understand the entire, now these are what, as we can see on the screen, these are different tools involved in different phases of DevOps, right? First of all, in the planning and coding phase, right? So here, what we do, we simply plan out how the application should be, what is the entire structure of the application going to be, right? And in the coding phase, we simply code, right? And again, now the most popular tool for planning and coding phase has been Git. We have SVM, then we have Jira, right? So these, now, although there are more than 15 tools available, there are more than 15 to 20 tools available for planning and coding, but we have to make sure that we use the global standards, because these tools are used by majority of the companies because of its efficiency and the ease of use, right? So that's why these are the most popular tools available for planning and coding. We have Jira, we have Git, we have GitHub, and SVN, right? So in coding, now Git is the most popular tool available as a part of VCS. Now, what we mean by VCS, maintain different versions of the code that we are submitting, right? And why Git is most popular? Because let's say we have a global team of developers. One team is sitting in Seattle, the other team is sitting in, suppose, in Tokyo, the other members are sitting in Singapore, and the fourth team is sitting in Mumbai, right? So instead of sending the code back and forth to our management team, what we can do, all of these different people, all of these different coders can manage and store the code in a single or a central server, right? And that we can use to start building the entire code, right? So all of these features are available in Git, and that we'll be exploring today as we continue further in our session here. All right. Next is, okay, first of all, are we clear on the planning and coding phase? Please give me a quick confirmation, guys. Are we clear on the planning and coding phase? We'll definitely explore this part in detail, but but till this point, are we clear on this point? Everyone? Anand, Feroz, Pankaj, Deepak. Okay, I have a query from Pankaj. So okay, from Ravi. So how Bitbucket is different from Git? So Ravi, we can say Bitbucket is more in terms of flexibility. It has more flexible options available as compared to GitHub, right? But as we know, GitHub is used as a global standard, right? So even though when we start working for any company, we start working on any project, then GitHub is more supported, right? So all the other platforms that we can think of, they all support GitHub as of now, right? So Bitbucket, although is more flexible, has an advantage over GitHub, but still the support for Bitbucket is not that great as compared to GitHub, right? And that's why we prefer using GitHub as compared to Bitbucket. Is it clear, Ravi? Please give me a quick information. Perfect. Thank you for confirmation. No problem. So Pankaj, so difference between DevOps and AWS Ops and Azure Ops. So Pankaj, DevOps is simply the strategy that can also be deployed on AWS and Azure, right? So AWS and Azure, Amazon Web Services and Microsoft Azure, these are simply the cloud platforms, right? And if we wish to incorporate the DevOps strategy on cloud services like these, again, we can do that, right? So they have their own specific tool set that we can use to get started on implementing DevOps strategy on cloud servers as well, if you want. All right. Perfect. Thank you for confirmation. Now let's assume further. Next is we have building. Now once the code has been built once the code has been done, the entire coding of the application or different functions has been done by the coders. Now we need to create a build out of it, right? For example, let's say now let's suppose a group of developers have been working on Java code, right? So obviously Java cannot be run on its own, right? We need to build the entire code. That means we need to create an entire build so that it can be executed properly, right? And for building the code, we have again three main tools available. We have Maven, we have Apache Ant, and Gradle. Again, there are more than 20 tools available for building as well, right? But Maven here is the most popular tool for continuous building, right? So that's why we use Mavens as the most popular tool available that we can use for building purposes, right? We can also use Gradle, we can also use Apache Ant. That depends upon the specific requirement. For example, let's say when we are working on a project when we need to use only Apache Ant, right? Then we can use Apache Ant. But globally and used as a global standard, Mavens is more popular as compared to other tools, right? As a part of continuous building. All right. Now, once we have built the code, obviously, as a part of DevOps, we need to do testing as well. We need to do testing as well, right? And now for testing, we use mainly Selenium and we use JUnit. For testing, we use Selenium and JUnit here, right? So Selenium again is the most popular tool for writing test scripts, right? Now we can also use JUnit along with Selenium. We can do that, right? But Selenium here is the most popular tool out there for writing test scripts, right? For example, once the code has been submitted by the developers, once the code has been entirely built as well through Mavens, now for testing purposes, we need to write a test script, correct? That means what exactly we are trying to test, that needs to be specified by using Selenium, and it can also be integrated using JUnit as well, a tool called JUnit, right? Absolutely, Pankaj. So Maven is easy to read and understanding is also easier as compared to other platforms. Absolutely, right? All right, so now once the entire scripting has been done, now we need a continuous integration tool through which what we can do, we can simply integrate. Now, once the test script has been done, once we have the test script ready with the code being built, then we have to integrate, then we have to deploy this test on the servers. On now, whenever we are performing any kind of testing, we do that on three main servers, right? We have test server, we have test environment, we have the integration environment, and then we have the production environment, right? So again, then now we need to run the test on these three main environments so that so that the feedback of the results of these three environments can be sent back to the coding team so that they can, in case of any bugs or any fixes required, they can perform that, they can execute that. All right. Now, in deployment and operation phase, again, we have two parts here. One deploys the entire application into the testing environment, into testing and staging environment, and one deploys the application to the production environment, right? And now here we have something called as containerization that we'll be discussing in detail as we continue further. And we have for containerization part, we have the most popular tool available called Docker, right? We have Docker, we have Vagrant. Now for virtualization, we also use Kubernetes as well, right? Whereas for configuration management, we have tools like Puppet, Chef, Ansible, SaltStack. So these are mainly used as a part of configuration management, right? So basically, configuration management is simply make sure that the entire application is good, is stable, right? Which needs to be deployed in the production environment, right? And as a part of our entire DevOps, at the end, we also need to keep a check. We need to keep monitoring the performance and health status of different components that we have deployed, right? And for continuous monitoring, we have multiple tools. The most popular tools out there are Nagios, Splunk, and Slack. Where Nagios is the most popular tool that we will be focusing on as a part of continuous monitoring as well, right? And for continuous integration, guys, we know the most popular tool out there is Jenkins, right? We also have Bamboo, we also have Hudson, but Jenkins is the most popular tool that can fetch the code because Jenkins has multiple plugin support because Jenkins can work with almost every tool out there that we can think of, right? It has a really great support for all the plugins, for all the tools out there, right? So if we have used any tools in the development, then we can integrate that easily using Jenkins. And that's why Jenkins is used in almost 80% of the entire 80% of the companies are using Jenkins as a part of continuous integration. All right. Okay, I have a small query coming from Dipti. So do we need to write test script as a part of DevOps or just setting up the tool? It's not writing scripts the job of the developer. Dipti, now developer's job is simply to write the code and deploy it. That's it, right? If that developer has not been given the responsibility of writing test script, but suppose if we have specific team members, those who are looking after test or after coding, those team members are looking only after the building process, only after testing processes, right? Then this can be the job of only that particular individual or team, right? But for example, suppose we are the sole DevOps engineer in any company, for example, any startups, right? Then we have to take care of writing the test script. We have to take care of integrating those test scripts and deploying them on the real on different environments. All right. So is it clear, Dipti? Please give me a quick confirmation. Perfect. Thank you for confirmation, Dipti. Okay, so I have a query coming in from Bhavik as well. So DevOps is used in cloud technology, right? Yes, Bhavik, mostly it is used for cloud technologies where we have deployed the entire application dynamically on the cloud platforms. We mostly use DevOps in those environments. Is it clear, Bhavik? Please give me a quick confirmation. Perfect. Thank you for confirmation. Okay, Pavan, so differentiate between Docker and OS instance. Sure, Pavan, let's focus on each and every on each and every module step by step so that we don't create confusion for others, right? We'll be coming to that part step by step as we continue further. Perfect. Thank you for confirmation. Okay, Feroz, so we'll have the demonstration on a cloud environment at the end of a session. Feroz will be focused now, as we are limited on time, we'll be focusing on one module, not every other, not each and every module here. We'll be focusing on one module and see how we can use it and how it is done as a part of DevOps. We'll be focusing on that. All right, perfect. So Bhavik, so mostly used cloud technologies are AWS, Azure, and GCP, and they have their own tools. Yes, Bhavik. So now, for example, now as you know, AWS is having the biggest market share, right? And just like we have GitHub, AWS has a service called Code Commit, right? So they all have their own tools and old tools and setup that we can use to start performing DevOps strategy on these environments, right? So the strategy, the entire setup remains same, only the tools changes. All right. Is it clear, Bhavik? Please give me a quick information. Wonderful. Thank you for confirming. Now let's proceed further, guys. Let's proceed further. Now, this is just now what we have discussed. Okay, first of all, let's clear this beautiful calligraphy of ours from the screen. Let's clear this out. Here you go. All right. So as we discussed, first of all, now these are different stages involved in DevOps. First of all, we have something called as version control. Now, version control simply maintains the different versions of the code as a part of source code management, commonly referred as SCM, right? We have SCM, and for version control, we also use an abbreviation called as VCS, as version control system, right? Now, when we say version control, what exactly we mean by version control? Let's look into this. Let me just draw this part out so that this can be clear for everyone. All right. Now, for example, let's suppose here we have a file. Let's suppose here we have a simple HTML file here with us, right? Now, in here, what we have is here we have added, now by default, we have done what? We have added H1, right? And we wrote some content inside H1 and then we closed it as a part of simple HTML page here. We have some content here and we close the HTML as H1 here, right? There's nothing else on this page. Now, this is what? This is version 1. This is version 1 here, right? Now, after some time, what we did, our client came back to us, and again, then it asked for a second version, right? So here we have H1. Here we also have H1, but here we also have H2. Here we also have H2 also added into the same code, right? And same way we have added multiple components, correct? Now this is what? Version 2, right? Now we also deployed the version 2 as per the client's requirement. We did that, right? Now the client came back to us and again they demanded another version, right? Now we have the same page. Now they don't want H1. They only want H2, right? Okay, we obliged, and then now we have written the entire code in H2, and then we have the code. Now we have the content also available in H2 here, in H2, right? Now this is what? Version 3. right? Suppose if this is one version v1, v2, and v3, right? And same way we can have n number of versions here. Suppose let's say we can have n number of versions here. We can have n number of versions as vn, right? Depending upon what the client is asking for, right? Now after now here we have different versions, right? Now after a while, suppose the client came back to us, okay, we don't like the current version. Now we want to roll back to the second version where we had h1 and h2, right? Suppose if we would have been replacing the code one by one, if we don't have any backup copies of these code of the second version, again that means again we have to come back and write the same code again and again, right? But as a part of source code management of when we have something as VCS, as version control system, what happens? We simply save the version of each and every changes happening to the code, right? So that even if we want to roll back to any of the versions at any point of time, we can do that, right? And this is what happens in VCS, right? And as we discussed, Git is the most popular tool as a part of VCS as a version control system out there. All right. So are we all clear on the concept of version control? Please give me a quick information, guys. Everyone, please give me a quick information, everyone. Wonderful. Thank you so much for confirmation, guys. Okay, Krishna, so H1, H2 are header files. Krishna, these are simply tags in the HTML pages. Like we have multiple tags in HTML pages, like we have header, div, paragraph, right? So these are also same kind of tags. All right. Perfect. Thank you for confirmation. Now let's clear this out. Now let's clear our $1 million painting here, right? As a part of a beautiful calligraphy, let's clear this out. All right. Now let's get right back. Now, as a part of our second module, here we have continuous integration, right? Now, once the code has been committed, now we move into validating and reviewing and preparing and compiling the entire code here, right? So suppose let's say we have a file for Java, right? So now as we know, Java cannot be compiled on its own. Java cannot run on its own, right? So we have to validate the entire code. We have to review the code here itself. We have to prepare a test script out of it, right? As we have seen, then we use Selenium, we use JUnit along with Jenkins for doing that, right? So that it can be built and it can be and then it can be passed on to the continuous delivery, right? Whereas once the build has been completed, then what will now like we have Jenkins, right? Like we have Jenkins. Now what Jenkins will do, it will simply pull the build that has been completed in the continuous integration part using Jenkins, and again it will simply deploy it to different servers, right? Like we have three main servers. We have test server, we have staging server, and then we have production servers, right? So it will continuously send the package to these servers for a quick feedback that can be generated once those has been tested, right? And that's a part of continuous integration, delivery, and deployment here. All right, as a part of continuous delivery and deployment. Right, now let's dive deeper into each and every of these modules. Again, as we know, each and every process also needs to be continuously monitored. That means we have to make sure that we have to keep a check on the health status for each and every stage. Like we have version control, continuous integration, delivery, and deployment. And we use tools like we have Nagios and Splunk for a continuous monitoring purpose. All right. Now next part is we have to go now. First of all, let's explore each and every of these stages one by one so that we have a deeper clarity on this part, right? Now in source code management, as we can see, for example, suppose here we have multiple developers working from different part of the globe, right? For example, here we have multiple workstations and they all are updating the code here, right? They all are continuously working on code updation, right? Now what they can do is, in a centralized version control system, basically VCS, we have two different types. We have a centralized VCS and then we have distributed VCS as a distributed version control system out there. Now in centralized version control, what we have is we have a working copy. That means here we have multiple workstations. Now these different developers are continuously working on the code on different parts of the same code, right? Then now once they are done, they can simply send their code and store in a central repository, right? So that it can now, so that suppose the end team or any kind of building environment, they need to build a testing, they need to perform testing, right? So instead of asking code from each and every platform separately, they can simply pull the code from a central repository, because again, each and every workstation are storing their code in the central repository itself, right? And then now here we have all these are directly connected to a central server as a part of centralized VCS, right? Whereas in distributed, again we have the same workstations, but instead of communicating directly with the remote server, what they are doing, they are simply first of all submitting the code. They are simply committing the code to a local repository, and once the entire and once the entire code has been submitted, then only it gets pushed to the central repository itself, or as a central server, right? So that suppose let's say when we are working on the entire page, right? Suppose in the same page there were 5 functions. Now either we can send those 5 functions one by one to the remote server, or what we can do, once the function has been completed, now we can store it local repository, right? And after completing all the 5 functions together, now it can be moved to the remote server in one go, right? That's the main difference between distributed and centralized VCS. All right. So are we clear on this part, everyone? Please give me a quick confirmation, guys. Are we clear on this centralized and distributed version control system? Feroz, Krishna, Pravan, Pankaj. Perfect. Thank you for the confirmation, guys. Now let's proceed ahead. Now, as we had discussed, the most popular tool for source code management is Git, right? So Git is basically not a centralized VCS, but Git is simply a distributed version control tool that can be used as a part of making sure that the entire code is submitted, and again we can simply work on the distributed VCS system as a part of our DevOps strategy, right? So here, first of all, again the same setup, the same setup is available in Git. We have the working space or the workstation, right? Then once the code is ready, then it is added to the staging area, right? And once the entire code has been pushed to staging area, then it moves to the local repository, right? Where it becomes ready to be again pushed to the remote repository where the entire changes can be recorded, right? Same way, if we have to pull any changes, suppose let's say now being a developer, we want to pull the changes submitted by other developers, again we can simply pull the code from there. Again the code gets pulled first of all to local repository, then again then only it becomes available as a part of workspace, not before that. All right. Okay, so I have a query from Mohan. So examples of distributed version control system. Show Mohan. Let us see a quick example here. Okay, Vinodhini, so can you please repeat Git? Show Vinodhini. Let's understand this through our beautiful calligraphy, right? Let's get right back. Sorry, guys. Let's get right back. So here we have something as pen, right? Now, let's suppose we are working on a project, a web development project, right? For example, let's say we have team. Now here we have team that is working on. Now let's suppose here we have a project. Suppose let's say here we have an entire web page, right? Now in this web page, here we have multiple components. For example, here we have a header section. Here we have a component for video. Here we have the component for RSS feed. Here we have the component for a dynamic listing of products, right? And so on. So here we have multiple different components, right? So here we have a header, here we have video, here we have RSS feed, and here we have a shopping list, or suppose we can say a product list here. Now these are different elements available, these are different functions available in the same web page, right? Now, for example, a developer starts writing the code. Now, this developer who starts writing the code here, right? Now, the developer will start functioning on its own workspace, on its own workspace, right? On its own workspace or work machine, right? On its own workspace, right? Now, the developer once the developer finishes the component for shopping list, right? Now, this and the code for shopping list can be first of all saved. Now, here with the workstation, now the same code can be saved in a local repository, here, right? And before local repository, we have one another setup which is called as a staging area, as a staging area here, as staging area, right? So first of all, once this code is ready, now this code is now pushed to the staging area, right? Now staging area makes it easier to recall the code instead of recalling the same code from local repository. Suppose now we want to make changes to the same code here, right? So again, it becomes easier to call the code back from staging area than calling it back from the local repository, right? Now, once we are done making the changes, now we can push code can be pushed to the staging area, again can be pushed again to local repository, right? Now, once all of this entire coding has been done, now here at the top we have what? Here we have a remote server. Here what we have? Here we have a remote repository, as a remote repository here, right? Now, once we are done with the entire code, now instead of pushing these code one by one, what we can do, we can push all the codes in one go, right? So instead of pushing this one by one, right? What we can do, we can create the entire piece of code can be pushed to the remote repository at once as a part of VCS. We can do that. All right. So are we clear on the basic setup for VCS, for a distributed VCS here? Please give me a quick information, everyone. And I hope you all don't mind our fantastic drawing here, which is again available for sale, can be auctioned as well, right? So first of all, are we all clear on the concept? Please give me a quick information. Yes, Pavan, this is for Git. As a part of, now this is simply a setup for Git here that we have explained. Perfect. Thank you for the confirmation, everyone. Okay, Ravi, I have a query from a couple of participants. So when to push a code? Okay, Ravi asked when to push a code, when to push the changes to remote from local to local repository. Now, let's suppose, okay, first of all, are we clear till this setup here, guys? Right, Ravi, are we clear till this setup? Perfect. Yes, Ravi, we can maintain multiple branches, right? Now, let's suppose there are multiple other team members. Now, we are not the only one who are submitting code here, correct? Let's suppose there are multiple other team members. For example, here we have another coder, right? They also pushing the code to this remote repository, right? Like we have the second user. Again, we have third user. They also pulling the code. They are also pushing the code to the same remote repository, right? So RS can store the code being submitted by, suppose, all the different users, like user 1, user 2, user 3, right? Now, as a coder, we want to pull the code that has been stored by another user. Still, we can request a pull for that code here. Then again, we can pull that code to local repository, and then again, we can start analyzing it. We can do that. All right. So are we clear on this part? Ravi, please give me a quick confirmation. No problem. Thank you for the confirmation. All right, so now I guess it's time to lose another $1 million. So let's clear out this drawing of ours, this beautiful caricature. Let's erase this all. And now let's move back. Now, next is we have continuous integration. Now, once we have the entire code being submitted to the to a remote repository, right? Then it needs to be tested. Now we need to create a build out of it. We need to add multiple testing scripts so that it can be ready. It can be made ready for testing purposes, right? And that's why we use Jenkins, right? So what Jenkins can do, that Jenkins can pull the code that has been made available in the remote repository, and then it can start building the code, right? So when we say build involves compiling, code review, unit testing, integration testing, and then creating a package out of it, right? These all are different stages. These are different activities that we can say it is a part of build, right? So first of all, obviously, suppose here we have a Java file. So again, Java file needs to be compiled first. The entire code needs to be reviewed in case there are no bugs. The entire code also needs to be validated, right? And then we have to write multiple testing script as well, right? So that we can create an entire package out of it that can be further delivered into the testing servers, right? For UAT. So UAT simply refers to user acceptance test as a part of UAT here, right? Okay, Abhikiri from Sarita. So why is Jenkins mentioned in the first row? It's Git, right? So Sarita, Jenkins. Now, obviously, once the code has been built, right? Once the code is being available in the remote repository, now we have to link this code with Jenkins server, right? So that, because again, Jenkins server will only pull the code from the remote repository for building the code. Correct? Is it clear, Sarita? Perfect. Thank you for confirmation. And now once the code has been pulled, has been entirely built, then only this entire build code has to be sent to the test servers. Like we have multiple servers, test servers, we have staging server, and then we have production server, right? So once the feedback comes from the test server, then the same feedback can be reported back to the coding team, right? So that they can perform changes in case of any bugs or any feedback received, right? And then we have then we deploy the entire build also to the production server, right? So that the real feedback from real users can be recorded. So once the application surpasses the user acceptance test, then we can perform the production server test, right? So now the code is becomes ready to be deployed to production server, where we can start getting real-time feedback, from different users. All right, as a part of our entire continuous deployment phase here. All right. So are we all clear on this part? Till this part, everyone, please give me a quick information. Okay, Krishna, so can you tell me about UAT? UAT is simply user acceptance test, right? Now, first of all, before we can move the code to the real world, obviously we need to test. That means if it is accepted. For example, let's say, as a small example, let's understand this by a small example. Let's say when we have developed any website, right? Now, obviously, we need to make sure that the same website is compatible for all the systems. For example, the same website is working well in Mac environments, in Windows environments, right? And also in Mac environment, if it is working well in only in Safari, only in Chrome, only in Opera, Firefox, or it is supported by all the different environments, right? So these are all different things that we do take care as a part of user acceptance test here. Is it clear, Krishna? Please give me a quick information. Perfect. Yes, Anand, Jenkins pulled the code. Jenkins can pull the code from GitHub. Is it clear, Anand? Perfect. Ravi is how to review the code after compilation. Ravi, we have to make, that's why we create multiple scripts here, right? So in Jenkins, what we do, we create multiple projects. We can create multiple pipeline, and then we can specify that which pipeline, which process is for which purpose. Suppose we can create pipeline for one pipeline object for compilation, the other one for code validation, and so on. We can do that, right? And we'll explore once we start our journey on the entire DevOps part. We'll see this one by one. All right. Is it clear? Please give me a quick information. Sure, Ravi, we'll revisit, get one more time at the end. We'll do that. Okay, Raghav, so is there any authentication we provide while requesting from Jenkins to our code? Definitely, Raghav. For example, let's say when we are trying to suppose, let's say we have a repository created in GitHub, right? So obviously we cannot, when we are fetching the code from our remote repository, obviously we have to validate, we have to authenticate us, right? So obviously we need to know the credentials for it. We need to specify the username and password. Only then we can connect to this remote repository, not before that. So clear on this part, Raghav? Perfect. Thank you for confirmation. All right, now let's get right back, guys. Let's get right back to our module. All right. Now, as we discussed, in making sure the entire code is ready to be deployed to the production server, we also have configuration management, right? So the basic idea of configuration management is to make sure that the entire system, the entire code that we have built, it is known, it is good, and it is trusted, right? That means the extensions used are well known, are popular. The entire course does not have any kind of security issues, right? And again, it simply does not conflict the understanding of the development team, right? And that's the main part of configuration management, and this is achieved by using multiple tools. Like we have Ansible, we have Puppet, we have Chef, right? These tools are basically used for as a part of configuration management here, right? And again, that's why we have three main staging servers. We have development, we have testing server, and then we have production server that we can deploy the code and test the entire feedback, right? So once we deploy the code to these different environments, development, testing, and production, then we can start getting feedback. So if in case there are any bugs, in case there are any kind of issues or feedback from real users, that can be again passed on to the coders for making their changes as a part of DevOps strategy, right? And as we discussed configuration management, first now the most popular tool out there is Puppet that we will be focusing on as well. So Puppet, now other tools involve Chef, Ansible, and SaltStack that we have discussed. But the main tool that we will be focusing on will be Puppet, right? So now Puppet works on two things. Puppet has a master and slave architecture, right? So now it works now. Puppet basically, first of all, what happens now here is a complete life cycle for Puppet. So first of all, the node sends the data back to the Puppet master itself, right? And again, this is all authenticated using SSL, right? Now, once the Puppet will use simple facts to compile a catalog, right? That means now it will simply contain the configuration details. That means how the entire node has to be configured, like different properties involved, right? Just like we maintain snapshots, out there, right? So here we have multiple, it will simply make sure that the entire file also has the configuration details, right? Again, it will push to slave here, right? Again, slave will report back that okay, the entire code that has been used, it complies to the configuration that has been pushed to by the master itself, right? And that will be visible in the Puppet master dashboard itself as a part of configuration management, right? And this is done to make sure that the entire code is having the configuration as required, so that it does not break in the real world scenario. So that now, even though the code was good, even though the coding, there was no issues in the coding, but the entire code does not have that kind of configuration. The entire build does not have that kind of configuration. Then it may fail in the real world or testing environment, right? So just to make sure that this does not happen, we have to take care of the configuration management, and we use tools like we have Puppet for performing that particular function. All right. Okay, Pawan, so is Docker same as Puppet? No, Pawan, Docker is a containerization tool. It simply provides a complete container, right? And that is we are coming to. So we have tool now. We have something called as containerization, right? Where now are we all aware of the concept of a VM as a virtual machine? Please give me a quick information, guys. Are we all comfortable? Are we all aware of something called as VM, virtual machine? Everyone? Right, Ravi, Pankaj, Firoz, Dipti? Krishna, yes, like a development host. Yes, Krishna. So VM, as we know, is a virtual machine that we create for testing purposes, for when we are especially working as a developer or a tester, right? We use a VM, right? And again, there are multiple VM tools out there. The most popular is Oracle VirtualBox, right, Ravi? Absolutely. So just like now we can say in containerization, what we do is we simply create a something resembling a VM, but the dependency, the amount of resources required for creating this container here, right? So when we say container contains simply the application itself, right? It contains all the binaries and libraries for that application on top of a Docker engine and a host operating system, right? So simply was same like we have a VM, right? But here the entire container is small, and again it doesn't have that kind of dependency and that kind of resource usage as compared to a VM altogether, right? So here that's why we have a Docker file called, which contains the entire project code, right? And it simply creates a Docker image out of it in the Docker along with Docker container as a part of VM, right? And then it is deployed to Docker Hub, where it can be further transferred to the staging server and can be deployed to production server, right? Where now, because again, any code needs a complete environment to run as well, right? And again, for creating that entire environment, we take the help of Docker, right? So where it can create multiple containers here, and then we can use those containers for testing purposes for deployment on staging server and production server both as a part of containerization tools. All right. Now, next we have continuous monitoring. So obviously, once we are done with continuous monitoring, okay, first of all, are we clear on the concept of configuration management and containerization part? Please give me a quick information, guys. So now we can move to continuous monitoring. Everyone? Anand, that's why we need containers, right? Obviously, that's why we need Docker to create those containers so that we can run the code. We can deploy the code on staging and on production environment both. All right. Yes, Pavan. So that's why Docker contains everything. It contains the OS, it contains in the source code and all the dependencies. All right. No problem. Now, as a part of continuous monitoring, guys, it simply maintains all the security and health check for each and every process that we had discussed, right? So it simply makes sure that the entire structure is running smoothly without any kind of issues, right? And in case there are some issues, then that can be detected, that can be reported back to the admin and the development team, right? And as a simple example, we must have seen that when we are using any kind of our Windows operating systems, right? Then suppose if we see a sudden shutdown, let's suppose when we are using our phones, like we have our iPhones or we have our Android based phones, right? We always get a bug, or suppose if those environment crashes, they simply ask us to send a usage or crash report, right? Because why they need to understand why the crash happened again, so that they can use this report as a part of continuous monitoring to improvise the entire delivery and the application further, right? And that's why we keep on getting multiple updates, right, everyone? Because if no report is being generated, if there's no system which is continuously monitoring the health status, right, then why and how we will get the updates, right? And that's why majority of the updates, as we must have seen, it contains the bug fixes and the security updates, right? And that's why we have these now, and that again, and that's why these are all a part of continuous monitoring. And then we have multiple tools that we have Nagios, we have Splunk for conducting these different continuous monitoring steps here as a checkpoint. All right. And that's what we have discussed just now. We have the most popular tool called Nagios, and Nagios itself has a complete GUI. So it has its own interface that we can use to see the entire report being generated once the entire system has been deployed, once the entire application has been deployed here as a part of continuous monitoring, right? All right, so now we have, after we have a good understanding on each and every process involved in DevOps, let's take a quick demo on, let's say, Git, right? Now, why we are choosing Git? Because Git is easier to understand, especially for those participants who have joined, who have no idea about the coding or who have no idea about the technical aspects of DevOps, right? So let's first of all start on Git. Let's see a short demo on how the VCS works as a part of DevOps. Let's do that, right? So let's see how we can get started on using VCS as a version control system on top of Git. Just a moment. Okay, I have a query from Surya. So what are advantages of using Docker on hyperserver? So Surya, basically, since Dockers are smaller, right? Now the containers in Docker, they are smaller, and again, that's why they are much better performing. They perform in a quicker manner and in a much better scale, and more scalable as compared to hyperserver. Hypervisor, sorry. So is it clear, Surya? Please give me a quick information. For a better performance, we use Docker instead of hypervisor. All right. Is it clear, Surya? Please give me a quick information. All right. So now let's get started on understanding the entire, on seeing a small demo on how we can get started on creating a simple VCS, right? So now for using VCS, what we can do, we have a simple, now first of all, if we want to install Git into our system, what we have, we can simply use a simple tool called Git Bash that is available for Windows environment, right? So Git Bash is not currently available for Mac. So again, if we have Mac, again, we can use Mac as well. We can install it on Mac, on Linux, or Windows, right? So if you now, first of all, we have to get started by using GitHub by Git Bash. So let me share this link with everyone so that we all can go ahead and install this. All right, so now let's get right back here. Now, once we have the Git Bash installed, then what we can do, we can simply go ahead and launch Git Bash. Let's do that. So here we can launch Git Bash. Now, once we have installed Git Bash, then we can go ahead and download it, and we can launch this, right? Now here, okay, let's zoom in so that we don't strain our eyes. We have a great visibility here. All right. Now, what we are doing here, we are simply, now, first of all, in terms of objective, what we are doing, we are simply trying to create a simple file, and we are simply now using the concept of Git, a simple distributed version control system here, right? So here we are simply trying to create a simple project where we'll be dividing that into the server, and first of all into the staging server, and then we'll be deploying that part, the same part, into production server as well. All right. not production server, but first of all to local repository, and then we will move that file from local to the remote repository as a part of our entire demo. All right. So now, first of all, in order to get started, first of all, we do have to create a simple directory here, right? So again, what we can do, we can create a simple directory for creating our project. So here we can use this one as make directory. Suppose we want to call the directory as Edureka 2 here, right? Okay, I guess this directory already exists. Okay, no problem. Let's do one thing. Since we have already built this directory in our previous demo, so let's change the directory here. So suppose now for changing directory, we have CD, right? So here we can use CD Edureka. So this directory is already available in our system, right? So let me show you what exactly is the component available in CD, right? Okay, I have a query coming in. Just a moment. Okay, Diti, so can you please increase the font size a bit more? Show Diti. Is this enough? Is this good, Diti? Please give me a quick information. Wonderful. Thank you for confirmation. All right. Now let's do one thing. Let's create a separate folder. Let's not use the same folder here. Let's create a separate folder here. Make directory. Here we can create a folder by the name of Edureka 99. For example, we name the folder as Edureka 99. And now let's change the folder, change the directory to Edureka 99. All right. Now let's see where this folder is currently located in our system. So here we can open up our system here. Let's open up our Explorer. Now here we have to go back to our system. Here we can open up our C folder. Now under C folder, currently we have stored where in C folder we have users, the username, and then we have the folder created, as you can see on the title bar, right? So let's open this up. Now here under Neeraj, we will be finding a folder called Edureka 99. As you can see here we have a folder called Edureka 99 here, right? Which is currently empty because we have not stored anything in this folder yet, right? So let's go back. Now here, first of all, to start using Git, we have to initialize Git in this particular folder, right? So what we can do, we can for initializing Git here, we have a simple command. We have a simple command called git init. Init stands for initializing the Git here, right? Now, as you can see here, now the Git has been initialized, and now as you can see here, there's a simple syntax called master that has been attached to it. A simple syntax called master has been attached to it, right? Now, next is once we have initiated Git here, now what we can do is we can simply start adding content in that particular Git folder. We can do that, right? Because again, currently, if we see the list of all the files available, if we want to see the list of files available, here we don't have any files available as of now. We don't have any files available as of now, so we won't be able to see any list here, right? Now let's suppose we add a simple file here. Let's suppose we go ahead and add a simple file. So let's say we open up Notepad. Okay, just a moment. Let's locate a file that we can use. Just a moment. Okay, let's suppose here we have a sample file that we can use as a part of a project, right? Let's go ahead and save the file in the same folder that we have created. So we go back to our Git folder in C, users, Neeraj, and here we have the folder that we have created, right? And once we have initialized Git in our folder, as you can see here we have the Git folder also available, right? Once we have initialized Git in this folder, right? So now we can name the file as demo.html here. We can name the file as demo.html, right? Now let's go ahead and save it. Now we can go ahead and save it here, right? Now, first of all, we have to add let's say when we are working on any file here, right? So whatever changes we make to this file here will be available as a part of version here, right? Now, once we have the file created, now next is what we have to do is we have to add this file to the staging area, right? we have to add this file to the staging area. Okay, just a moment, guys. Let us plug in to the system. Just a moment. All right. Now, once we initialize this one here, now we need to add a file. For example, what we have is here, if we look at here, we have the file for HTML here, right? Now, let's suppose now what we want to do is we simply need to add this file. We simply need to add this file here, right? So now let's suppose we go ahead and do that. So for adding the file here, what we have is we have a simple command called as git add. We have git add, right? And here we have to specify the file name that is currently available in the same folder. So in the same folder, what we have demo.html, correct? So here we have to specify the file name, that is demo.html. Now what it did, it simply now moved the file from the workspace, that is this folder. Now this file is available in the staging area, here, right? And to see the information for staging area, what we can do, we can simply use another git command called git status here, right? Now, as you can see here, currently we have this file that is currently available in the staging area that is waiting to be committed, right? When we say committed, we simply mean that this file is now ready to be moved to the local repository. It's now ready to be moved to the local repository here, right? And if we suppose if we use this command called git commit, if we use a command as git commit here, right? Then what will happen? This will simply push this code to the, suppose if we use git commit, and suppose if we want to commit all the files, now we use A for making sure that we commit all the files that is available in the folder. Currently we have only one file, so only one file will be committed, right? So here we can use the m command. Now we have to specify a message as well. When we are committing, we can simply specify a message called suppose committed as a status update, right? Now, as you can see here, one file change, and again, this has 11 insertions. That means now we have 11 components in this file that we are working on, correct? Since we have 11 lines of code here, right? That means there are 11 insertions, all right? And now the code is now moved to the local repository here. Now the code has been moved to local repository, as you can see here. All right. And that's why what we had done is we have simply made sure that we have created one file, and now we have added this file to the remote repository that we can get started on as a part of our git command, right? So are we all clear to this part, everyone? Please give me a quick information, guys. Are we all clear till this part? Please give me a quick information, everyone. Perfect. Thank you for the confirmation, everyone. And now let's suppose when we are trying to make any changes here, right? For example, let's say we go back and we make any changes in this document. Let's suppose we add a simple H2, right? Let's suppose we add a line as we are learning DevOps. We are learning DevOps. So here we can add this line here. We are learning DevOps. And then we can close this H2. We can close this H2 here. Once we save it up, we come back here. Now, as we know, this is a part of version control system here, correct? So if we use a small command called git difference, right? So this will simply point the, now since we are using a version control, so this will start maintaining versions for it, right? And as we can see here, this line we had added just now, and this has been reflected as a second version, as a second version. And what the change has been, this can now be reflected as a part of git. So is this part clear, everyone? Please give me a quick information. As a starter for the version control system and how Git will help us in maintaining different versions, please give me a quick information, guys. Perfect. Yes, Iti, we can use Git to connect to a GitHub repository as well. We can use this to connect to any local or suppose any particular remote repository. We can do that. Perfect. So I guess since we are short on time, so let's first of all look into our community, look into our meetup community. Just a moment. Yes, Krishna, we can create branches as well. Like we can create multiple branches so that we can, the basic concept of branches, we use branches to keep a different version of the code running in parallel, right? For example, let's say we are modifying all the changes, right? So we can modify all the changes in branch, and then once we are done with those changes, then we can combine that branch with the master. We can do that. Is it clear, Raghav, Krishna? Perfect. Thank you for the confirmation. Yes, Raghav, we can do that. Now, if we want, we can add a remote repository as well. For example, let's suppose if we want to add a remote repository, then we have a simple command called git remote add, and here add origin, because now origin is the alias given to the remote repository. So sorry, to the remote repository, and master is the alias given by Git itself to our local repository, right? Suppose let's say we have a Git account. We have a Git account there. Suppose we have a Git account like this one. So we can copy the link here. We can use the link here. Suppose let's say we have HTTPS. We have github.com / we have the username, and again / here we have the name of the repository as Edureka99.git, right? So basically what we are trying to do is we are simply trying to add a remote repository. So now, as you can see, this has been added, right? And now if we want to push what we have created to the remote repository, right? Then we have a simple command called git push. Now, first of all, we have to mention the remote repository, that is origin. Origin is again the alias given to the remote repository. And now from the master, that means from where we have to push it, right? So once we click on enter, this will push the files available in the local repository to the origin. Okay, I think we did not push this to local repository. I think we may have missed that. Because again, first of all, as we discussed, we need to have files in the local repository first, correct? Okay, query coming in from Pankaj. So how to create the merge request to merge from local repository? That is a part, again, that will take a bit of time here, Pankaj, and that's why we are limited on time, right? That's why we are focusing on that as of now. Perfect. Thank you for the confirmation. All right, so that's how we can get started on pushing. And again, if you want to add any remote repository, then we can do that as a part of our Git account, here, right? And let me showcase you something, guys. We do have something called, okay, just a moment. All right, so now as you can see here, guys, on the top, we do have something called meetup.edureka, right? .com/Edureka. So here we are simply building, now here we have been working on building an entire community, right? So here we have been building, let me share this link with everyone. So I would request all to join this entire community. Now, the main advantage of joining this community is we can be notified on any kind of webinars that we are conducting on a regular basis, right? So in any given month, we are conducting more than 100 webinars on different topics, including data science, DevOps, AWS, cybersecurity, web development, app development, right? Python. So there are multiple webinars that keeps on happening on a regular basis, and these are all free. We don't have to pay anything for getting enrolled into this. And again, if we do enroll into any of our courses as well, right? And if we are part of this community, then we are eligible to get some handsome discounts as well, right? So please do not forget to join this entire community here, right? And again, as we can see here we can find the list of all the upcoming events for the entire training that we are conducting, right? So as you can see here, currently we have this training ongoing, right? Again, we have another training ongoing scheduled at this time, right? And here we can see the list of all the trainings, all the webinars that has been conducted, right? So we can join any of these particular webinars, and we have different topics assigned for different webinars, right? We have different topics ongoing every month, and this can be a really good place to get started on getting some good insight on different topics out there, right? We can use this to get some different insight, a good insight where we can use this, right? All right, so I guess it's almost time now, guys. So at this time we'll be wrapping up. So I hope you all enjoyed our 90 minutes together. I hope you really enjoyed what we have shared, what we had discussed over DevOps. And first of all, I would like to thank you all. Thank you so much for joining us, for making this entire webinar successful. So thank you so much for joining, and I hope you all had a great 90 minutes. And at the end of the session, you all will be getting, all the participants will be getting the NPS feedback form. So please do rate us excellent in that feedback form as a small token of appreciation for the hard work and time that we have put in. And hope to see you all joining for the entire session for another webinars coming up super soon. All right. Thank you so much for joining, guys. Have a great day ahead. Thank you so much. Take care. Bye-bye.